The significance of our protocol is that it lowers the detection limit, making it possible to study the concentrations of minor species that other methods cannot reach. The main advantage of this technique is the addition of the Upconversion module, which circumvents much of the background noise.
Work with the setup for upconversion used in the detection process. Begin by exposing the internal elements in the setup. A laser diode and crystal produce a 1064 nanometer beam. A series of mirrors directs this beam through a PPLN crystal and back. A mid-infrared beam from outside also goes through the crystal. The two beams produce an upconverted signal that exits the PPLN crystal and goes to a detector. This schematic provides an overview of the setup. The crystal used with the laser diode is neodymium-doped ytterbium orthovanadate. The symbols U1 to U7 are mirrors that are highly reflective at 1064 nanometers. Mirrors U1 through U5 are highly transmissive at the wavelength of the laser diode. Mirror U6 is transmissive in the range of the upconverted signal. Mirror U7 is transmissive for the mid-infrared signal. The mirror U3 has a 200 mm radius of curvature. The other mirrors are flat. Use a flat mirror on a kinetic mount to establish an alignment cavity. Place the mirror in front of the laser medium to serve as the end mirror. Turn the angle of the mount to extreme positions in both the horizontal and vertical directions. Next, place an infrared sensitive beam card in front of mirror U2. Also remove